All right, here is my video guide for the lesson 812, and I'm going to say that's day one. We might continue to do more of this tomorrow, depending on how far we get here. This is a little bit longer of a lesson, so I'm going to try to do it in one video, but it might take two, because the purpose here and the idea here is a little bit longer, a little bit more in depth, and I want to try to explain it completely with being virtual like I am. The purpose being that we want to understand how to set up sine and cosine equations that model real-world situations. And we're going to do that by first looking at 8.6 from the 8.11 lesson, which was yesterday. And then we have a couple extras, 8.16 to 8.19, to evaluate it further here today. We need to go back to 8.6 from yesterday because I skipped over it, and it's going to be important to understand how we're going to do this here today. There is some homework here. I'll put that in Google Classroom. Make sure that you're trying your best to do the homework. I think if I do a day two of this lesson, I won't post another homework for it. We'll just have to kind of wait and see there. Without further ado, I want to get into the lesson to give myself the most time to explain this as possible. Again, it might take me 2 videos on this one, but we have 60 minutes of class, so hopefully that'll be okay. Looking at this problem, so I'm going back to yesterday's, which if you're on your ebook or whatever, you might have to flip back to 8.11, not too terrible to do, or just watch this portion of the video to understand how we're going to do the problems here today. I'm going to pause, or you can pause this video for a second, and then read the problem, make sure you note the important parts of it, and then I'm going to start with part A. What it says here is that we are going to assume the graph is a sketched and shifted sinusoidal wave, so that's like sine and cosine. Copy the sketch and label the coordinates of the 2 known points. Now, you don't need to copy the sketch. In fact, for most of today, we're just going to use Desmos because I'm not in person to understand this, to see this, and for me to do it virtually. For us to do this, meet with me virtual, it's better to use Desmos. But we can see, based in the directions and based on the graph, that we have 2 known points. The first point is at its high, which is at 0.4 and 46. And so I'm going to make note of that point, which is, again, 0.4 seconds, and it's at its peak of 46 centimeters. The second point here is when we have the stopwatch at 2.2 seconds, and that's when it's at its low point of 26 centimeters. And we really like to start high to low, especially if we're going to use a cosine function, which is what we're going to do, and we'll see that as we continue doing problems here today. But here, that's the high point, now into the low point, which is 26 centimeters. And then those are the 2 key points that I know. And really, those 2 key points are going to help me do this entire problem. Luckily, we have the graph here, but as we get into the problems of 8.12, we won't always have the graph. We're going to have to create that equation. Part B here, we're going to use these 2 points in the graph too to state the period, the amplitude, the horizontal shift, and the vertical shift needed to transform this from just being a basic cosine function. Now, this is super important, and this is going to be utilized as we continue on into 8.12, so make sure you're paying attention here as we do part B. Let's start with the period of the function. Remember, the period of the function is how long it takes the function to start repeating. Okay? And so when I look at this, I see that, and even just using my points, that in a 1.8 seconds, I'm halfway to that repeating point. 1.8 seconds takes me from the high to the low, which means another 1.8 seconds, I'm going to be back at the high, and my function is going to start repeating again. Okay? And so what that tells me is that the period of my function is 1.8, but then another 1.8 so that it starts repeating, and so that gives me a period of 3.6 seconds. Okay? Now that's important, and we'll use that as we continue on. And really, if we wanted to see another point that would make that more clear, 1.8, another 1.8 would put me at 4 seconds, and at 4 seconds, I would be back at 46 centimeters, and you can actually see that point right here at 4-46. And that's the entire period then of 3.6, brings you back to the start. The next thing is the amplitude, and with the amplitude, okay, we need to figure out how high this is going from its midline, okay? And one way to figure out that midline of this function, or there's two ways that we can really do this, and I'll go through both of it because it's going to be helpful. Let's find that midline of the function because that's going to help me figure out the vertical shift when I get there. And to find the midline of the function, what we can do is actually just find the midpoint between these 2 points in the height, which is 46 plus 26, and that gives me 72. And then to find the midpoint there, we just got to divide that by 2, which gives me 36. What that means is here at 36 is the midline of my function. And the amplitude is then the height from the highest point to that midline, which from 36 to 46, or even from 36 down to 26, that is an amplitude of 10, okay? So that is an amplitude of actually 10 because amplitude is the height of the wave, again, from the midline to the highest point or to the lowest point. And that, again, from 36 to 46 is 10, okay? The next thing is the horizontal shift. So the horizontal shift is how has this function been shifted over. And with the cosine, the highest point, or the first highest point, is generally the starting point for cosine. So we want to say, well, how much have we shifted over from the y-axis to my highest point there? And we've just shifted over 0.4. And so my horizontal shift is 0.4. And then my vertical shift is that midline. How high up is the midline from the x-axis? Because generally the midline of the function is on the x-axis, and that's normal with cosine or sine functions. Okay? And so here that midline was up at 36, like I did the math to show, and that tells me then I have a vertical shift up of 36. There's 36 units there. Now I'm going to put these all together to create the equation that they want me to do in part C, and the height above the floor, right, representing an equation in terms of h and t of the height above the floor that this spring is in the problem. Okay, remember that the equation is going to be y equals a, which is your amplitude, cosine of b, and then I'm going to have a t value, which is going to stay t, minus your h, which is your horizontal shift, plus your k value, which is like your vertical shift. Sorry for the messy cosine there. But we have all these pieces to plug in and have an equation that's going to be actually not y, but h of t. And that's going to be h of t equals a, my amplitude was 10, times the cosine of, now my b value is kind of weird. And this is going to be something that we'll just do throughout the lesson here today. But that period of 3.6, that's not necessarily your b value, because your b value is how many periods happen within 2 pi. And so to actually represent my b value here, and this is just going to be something that we need to get accustomed to, my b value is really going to be 2 pi divided by what I called my period, which was 3.6. That's my b value. Okay, and that's going to be consistent. We're always going to do 2 pi divided by what we called the period to end up getting that b value. Okay, so that's 2 pi over 3.6. T stays at t, minus my horizontal shift, which is 0.4, plus my k value on the way outside, which is my vertical shift of plus 36. And even if you went and typed that into Desmos right now and paused the video, you would see that that would give you that same exact curve of that right there. Okay, so that is an amplitude of 10. That is a b value of 2 pi divided by my period of 3.6. This is a vertical shift to the right of 0.4, and then a vertical shift of 36 going upward. Okay, let's keep moving so I can get this next problem in this video. And this one goes into 8-16, which we do not have the graph, but we're going to have to take the information from the problem and create an equation. And the points, the 2 points that we're going to be doing, which is going to be a high point and a low point, are going to help me create this equation. So pause the video here, read this problem to your group, take the information out of it, and then I'm going to start with part A. Now in part A, it wants us to write an equation to model the height of the water relative to the post as a function of time where t equals 0, and that means 12 o'clock midnight. And h of t represents the height of the water in inches. What we know from this problem is that the lowest level of the tide is 2 feet. And so it says the low point is at 8 a.m., which would be t equal to 8, and it's going to be at 2 feet. And we're going to do this in inches. And so when we have this is part A. When we have t equal to 8, the water level is at 24 inches, which is 2 feet. Okay, and that's the low point. Then we hit a high point at 2 p.m., which is 14 hours from midnight, or 0. So that's 14, comma, the high point, which is, I think they say the high point is 40 inches higher than its low point. And 40 inches higher than 24 is 64. Now, I'm going to represent this with a cosine function just based off of the first problem. And right now we're going low to high, and I want to go high to low when I use cosine. So I'm actually going to go back one more. I can see that every 6 seconds I'm going to go low to high. So that means at 2 a.m. in the morning, I'm going to be at a high point of 64. And that's really the point that I'm going to use to start to go from high to low here. Okay? And right here, actually, I have enough information to create this function, and then I'm going to graph it on Desmos to pretty much answer the rest of it. And I got to kind of hurry up here so I don't run out of time, but I know I'll need a second video here. Doing this now to create the equation, I'm going to start with the period of the function. Now, the period of the function is, again, how long it takes to go through the entire thing. So high point back to high point, we see that it takes 12 seconds there. Okay? So my period is 12. My amplitude of my function, well, this one's not too bad. I actually can see that I am going to have an amplitude, and let's do this just for the sake of time. I'm going to have an amplitude of 20. And we'll go to the vertical shift and talk about why that is. But amplitude of 20, I have a horizontal shift over, starting with my first high point of 2. So I'm shifting over 2 units to the right. And then I have a vertical shift up of 44. So let's talk about this for a second. You can go back to the other method. If you did 24 plus 64, okay, and then divided it by 2 to find the midpoint, you would get 44. Okay? And then what you can do is you can also say that when you're at 44, which is that midline, 20 more than 44 brings you to 64. 20 less than 44 brings you to 24. So it is the amplitude of this function. This allows me to create the equation, which is h of t equals your amplitude, which is 20, times the cosine of what would be 2 pi divided by my period, which is 12. And if anybody can see that, that's really just pi over 6. And then it's t minus 2 for my horizontal shift plus 44 on the outside. Okay? Now, when they want us to answer this question, and I'll have that graphed and we'll see it in Desmos in a second. When we want to answer this next question and it says the girls are walking on the beach but decide to wait until high tide, what was the height of the water at 11:30? Well, for us, 11:30 is a t value of 11.5. Okay? And so what we would do is we would take our equation, we would plug in 11.5 into it and see what the height is at that time, and that's what I'm going to do on Desmos. But before I do that on Desmos, I'm going to look at when this curve is at 2 feet and 7 inches, which is in total 31 inches tall. Okay, and we're going to see when the first time after 8 a.m. that's going to happen. So let's bring open the Desmos quick. I know I'm running out of time. I can see my timer, it's counting down. This is my first equation here, 20 cosine of pi over 6, t minus 2 plus 44, and it brings out this sinusoidal function. Okay, the big first one is when is my y value going to be equal to 31 inches? We can look at the first one. Well, that's at 6.35. That's before 8 a.m. So we don't want to use that one. So we want to use this one, which is 9.64. That's the first time after 8 a.m. that we'll hit 31 inches and that little brother's head would be under water there. To figure out what the height of this function would be, or what time that the water would be, the height of the water at 11:30, What we're going to do is we're going to plug 11.5 in for t, my t value here, and it should give me my answer, which it does, and the height of the water at 11:30 a.m. is 49.176. I'm out of time on this one. We'll pick up with a couple more problems on the next video.